Next, we have double decomposition or double displacement or metathesis. So in this case, we have two compounds with different partners. We have AB, then CD, but after the reaction, they have swapped their partners. So we have A and D, this one, then we have B and C, this one. So this is the format for this type of reaction. The first type of reaction is when we have a precipitate or we have precipitation reaction. This is when there is a formation of a solid substance that is formed after the reaction. As what we can observe here, before the reaction we have substances in aqueous solution, that's AQ. This means that this one is dissolved in aqua or water. So again, these substances are dissolved in water. Then after the reaction, there is a formation of a precipitate. That one is a solid substance. So we can see here, there is a solid. So S means solid. So for example, this one is the, let's say we have put this sodium nitrate and then this sodium chloride dissolved in water on this reaction. Then after that, we can see here a precipitate. This one is the solid on this case. Then as what we can observe here, they have swapped their partners. We have Ag, then we have the Cl, then we have the Na, then we have our nitrate. Then as you observe here, the first part is always the positive part, then this one is the negative part. The same thing for this positive, then the negative is the Cl. Then as what we can see here, the first part is always the positive one. We have silver, then since Cl is negative, it's on the last part. The same thing for this one, since again, the sodium is the positive one. So it's on the first part here. Then since the nitrate is the negative one, this is written on the second part of the formula. The same thing for this one. Again, we have these substances formed a precipitate, a solid substance after the reaction. So here we have lead, then we have the CrO4 here, then we have potassium, then we have our nitrate over here. Then the next one we have neutralization. This is when we mix acid and base. So they neutralize each other, And from this reaction, we have salt and then water. So for example, here we have HCl plus NaOH. So the common sign of an acid is that merong, again, it's acid pag merong hydrogen on the first part. Then pag may OH group, that one is a base. Again, acid, then we have a base over here. Acid, then we have a base over here. Again, the product is a salt. We have NaCl. Then we have a water, H2O. Let's proceed to the items over here. Which of the following is a double decomposition? So commonly, it's composed of two parts, then two parts. So number 3 is the same with this one. So we have this one. So again, this is a double displacement. So this one will partner with this one over here. So this one is an acid, merong hydrogen, then we have a base, merong OH group. So this one is the same with this one. Again, we have a formation of water that is from this one, and then this one over here, OH plus H, we have H2O, plus we have NH4, and then we have the SO4. Then for this one, let's check the, again, I just change their partners. Again, that is we have NH4 partners with the SO4. Again, since NH4 is positive, it's on the first part. Then since SO4 is negative, this is on the second part. And then to check the charge here, SO4, for the SO4 we have -2. That is -2. We have -2. Then for the ammonium, we have +1. Again, +1 for this. So -2, then +1. So we need to double this ammonium over here. +2, then -2. So this one is the product. These two are the products of this reaction. Then we also have number 7. We have again dalawang ports, then dalawang ports. So for this one, we have Fe. It will partner with the CO3. So in this case, outside, outside, then we have inside, then we have inside. We have FeCO3, FeCO3, and then we have the NH4, then OH. Then let's check the subscript over here for the iron, or let's proceed first with the carbonate. So for the carbonate, the charge is -2. Then again for iron, we have +2 also, so this is enough for now. Let's proceed to the NH4, then the OH group. For the NH4 ammonium, that is +1, +1. And then for the hydroxide, we have -1. So it's also neutral by this formula. So these are the products for this reaction. Then we also have number 8. So number 8, we have potassium hydroxide. Again, outside and outside. We have KPO4 plus. We have H3 plus OH. This one is H2O. Let's check the charge of this one. Potassium is +1. Then we have phosphate. For phosphate, we have -3. Let's add here 3, +3, then -3. So these are the products for this reaction.